In the given question, we find that a smooth cylinder of diameter 4 meters is lying in the triangular groove of which makes an angle of 10 degrees and another angle of 30 degrees with the horizontal. So this is the cylindrical trough, cylindrical roller which is resting in the triangular groove, and we are supposed to calculate the reactions of contact when there is no friction between the surfaces and weight of the cylinder is 150 Newton. So the weight is going to act downwards. This would be the weight of the cylinder passing through the center. Okay, so now here there is a contact. Due to the contact, we know there will be induction of normal reactions. So normal reactions will be there. So this is the normal reaction due to the surface number 1, and similarly we would have another normal reaction due to the surface number 2. So now let me write it as R1 and let me write this as R2. So we need to mark the angles. So here this would be 90 degrees since it is perpendicular to the surface number 1 and it is passing through the center. So it will be 90 degrees. And the angle R1 is going to make with the horizontal will be 180 minus 90 minus 10, that is equal to 80 degrees. Same way, here I can extend R2. This would be extension of R2 and this is the extension of horizontal. Okay, so the angle here included will be definitely 90 and this would be 60 degrees. So now I need to join these forces, or these forces are passing through the center of the sphere. Let us call that point as O. So let me just draw this point O separately over here. So this is force W that is passing through point O, and let me place it at this point. Same way, this is force R1. Let me place it ideally at the point O, and next is force R2. Let me place it over here. So we find that there are 3 forces acting at the point O, and now the theorem that is applicable over here is Lami's theorem. Okay, so we need to just mark the angles as it is. This would be R1, this would be R2, and R1 is going to make an angle of 80 degrees with the horizontal. So which means with W, the angle included would be 170 degrees. And same way, R2 is going to make an angle of 60 degrees with the horizontal, and the angle included with the weight will be 90 plus 60, that is 150. So now the angle subtended between R1 and R2 will be 360 minus 170 minus 150, which is 40 degrees. So now we have got all the angles included between the forces, or 3 coplanar concurrent forces. We can apply Lami's theorem. And one more thing, here the cylinder is in equilibrium, which means R1 and R2 has to pass through the center. If the cylinder is about to experience rotation, then there has to be a one force which is away from the center, or either it could be even tangential to the surface. So now here if we apply Lami's theorem, that is 150 by sine 40, that is equal to R1 by sine 150 equal to R2 by sine 170. So upon solving this, we would be getting R1 as 116.7 newtons and R2 will be equal to 40.5 newtons.